Today's objective is multiplying monomials. Now, monomial is kind of a strange word. You know, mono means one, like at Disneyland, the monorail, or those glasses with one piece, one lens, a monocle. But monotheism, you learn about this year. But it just means one. So basically we have one term, but it's made up of it's made up of a combination of numbers, variables, and positive exponents. Technically, you could just say a single number or a single variable is a monomial, but we're using the combinations. So, like 3x squared. Okay, so we have a number, a variable, and exponent. Negative 8 x squared y to the fifth. A number, it can be negative, and a couple of variables with exponents. 2/3 x squared. You could say 2x squared y divided by 3, or 2/3 x squared y. That's a monomial also. So what we're doing today is we're multiplying them. All right, and we multiply by rearranging and multiplying like terms. Because remember, this is where we talk about the properties. The commutative property, you can change the order of multiplication. So that's what we're going to do. 2x cubed times 5x squared. Well, we're going to rearrange and put our coefficients, which are the numbers you multiply the variables by, together, and then we'll put all our like terms, all the same variables, the same letters, together. So I'm going to rewrite this so it's 2 times 5, I took my 2 and my 5, and my x cubed times x squared. Now remember, the exponent tells you how many times to write down the variable. So x cubed is really 1, 2, 3 x's, and x squared is really 1, 2, 2 x's. This was the video from before. So when we're multiplying this, we say 2 times 5 is 10, and x cubed times x squared, well, you could write them all out and count them, but you could also add the exponents up. So 2 plus 3 is 5. So it'll be 2x cubed times 5x squared equals 10x to the fifth. Let's do another one. Negative 8 m to the fifth n to the third times 4 m squared n to the fourth. Let's rearrange it. So we'll put our coefficients together, negative 8 and 4, our m to the fifth and m squared, our n to the third and n to the fourth. And I wrote it out for you just so you remember what it means. These 5 m's and 2 m's. So how many m's? 7, and that's what 5 plus 2 is. And 3 n's and 4 n's, also 7. So negative 8 times 4 is negative 32, m to the 7th, n to the 7th. So it's really pretty easy. You're just multiplying your coefficients and then adding up your exponents. Here's another one. 6a to the third b times negative 4b to the fifth. Notice this one has 2 variables, but this one just has 1. So we'll rearrange them. 6 times negative 4, and this time I put the negative 4 in parentheses because it came second, and I didn't want you to think that it was 6 minus 4, okay? Here I didn't have to because the negative was first, so you wouldn't think it was a subtraction problem. And then a to the third, b, and b to the fifth. There aren't any other a's to multiply. So 6 times negative 4 is negative 24. A to the third. What does this b mean? That's a really long bell, isn't it? How many b's are there? Well, remember, if there aren't any exponents, it's because there's only one b. So if you would like, add this so you remember when you add 1 plus 5 is 6. Okay, I don't want you to make the mistake and just not think and just say 5 because there's one more here. All right, let's do a few more. Sorry. 3a to the third b squared times negative 5a to the negative 5b squared. Now I've put a negative exponent up there. So I'm going to group my like terms together. 3 times negative 5, a to the third times a to the negative 5, b squared times b squared. Do exactly what I did before. Multiply my coefficients. 3 times negative 5 is negative 15. Add my exponents. 3 plus negative 5, negative 2, and add my exponents. 2 plus 2 is 4. But no negative exponents are allowed in final answers. So we have to remember, what do you do with a negative exponent to make it positive? Okay, what do? Well, we change where it is. This, technically I could write this whole thing as over 1, right? Because any whole number you can make into a fraction by putting it over 1. So currently the a to the negative second power is in the numerator of this fraction. To make it positive, we have to move it to the denominator. So I'm going to rewrite it. Negative 15 would have a positive exponent. It stays in the numerator. B to the fourth stays in the numerator. The only thing I have to move is the a to the negative 2. Okay, so that goes down in the denominator. Now don't get confused and say, oh, a negative. It's only a negative exponent. Okay, negative 15 would still be negative 15 to the first power, and that's positive. So it stays there. Okay, so you have to do a little bit more thinking, and you have to move your negative exponents. Here's another one. Negative 3 p squared r times 6 p to the third r to the negative fourth. Group our coefficients, group our like terms for our variables, and now let's multiply. Negative 3 times 6. Oops, I forgot my negative, huh? Negative 18. P to the second times p to the fifth. That's 1, 2, 3, 4, 5. Add them up. And r, remember this r has a 1. 1 plus negative 4 is negative 3. Now, am I finished? No, because I have a negative exponent. So this is really going to be negative 18 p to the fifth divided by r to the third, because that has to go down into the denominator for our final answer. And we're done. All right, here's another thing. What if I have the quantity of 2x squared y to the third, that whole thing to the third power? Notice this is different because this has an exponent right next to a parentheses, or exponent next to an exponent. This 3 doesn't have its own base. See, what I mean is this y to the third, this 3 belongs to the y, this 2 belongs to the x. This 3 just is for the parentheses. So what that means is write everything in the parentheses this many times. Because remember, the exponent tells you how many times to write down the base. So this really means 2x squared y to the third times 2x squared y to the third times 2x squared y to the third. Okay, it means write it down that many times. Now you can, so this is a two-step. Now you group your coefficients together and your like variables together. So I'm going to say 2 times 2 times 2, x squared, x squared, x squared, y to the third, y to the third, y to the third, and then just multiply. 2 times 2 is 4, times 2 is 8. Don't say 6, okay, you're not adding, but you are adding up your exponents. 2, 4, 6, 3, 6, 9. Okay, so when you have a parentheses with an exponent, you need to write it out before you can group it together. Here are 2 more examples. What if I had the quantity 4x to the third power? Well, that tells me to write the 4x 3 times. 4x times 4x times 4x. So 4 times 4 times 4, x times x times, what the heck? What the heck did I do there? X times x times x. I don't know why I did that. So 4 times 4 is 16, and 16 times 4 is 64, and then 1, 2, 3, 3 x's. That was easier. It's easier when you only have one coefficient, one variable inside your parentheses. That's why I wanted to do a harder one. Let's do this one. 3a squared b to the fifth c squared, that quantity squared. So that means write it down twice. 3a squared b to the fifth c squared times 3a squared b to the fifth c squared. I'm not going to stop through this bill. So 3 times 3, a squared, b fifth, c squared. And then just multiply the coefficients and add your exponents. 3 times 3 is 9, a to the fourth, b to the 10th, c squared. It's kind of like a little puzzle. It's kind of fun. All right, that's it.